Have you ever struggled with understanding and viewing ligand contributions to computed XES spectra, or are you simply interested in being able to visualize this concept? If so, I'm here to help. My name is Nicole Danielle Avila, and I'm a senior graduating in spring of 2022 from Cal Poly Pomona. I'm currently conducting research in Dr. Stieber's lab, where my focus has primarily been computational electronic structure, information, and determination. Today, I will guide you through an amazing program called MOAnalyzer, where we can actually see the contribution to XES spectra from ligands. As with every great lab experiment, you need great lab equipment. I will link all of the programs that you can find online in the description box, along with the paper that MOAnalyzer was published along with. But as far as this tutorial, you will need MOAnalyzer, Crimson Editor, or the Mac equivalent, Excel, an XES.out file, it has to be from Orca, and a notepad. Welcome to MOAnalyzer. When you install and open MOAnalyzer, a mini window should appear. Close this window right away and select Load, and remember, it has to be a .out file from Orca. So I click this, and then I go into the file that has the out file that I'm interested in. Great. So the first section that we should focus on is numerical analysis. There are a few sections here and we'll take it step by step, so don't worry. I like to begin with figuring out how I want to position my complex. So I always like to hide hydrogens. It makes it look a lot cleaner. Then you can actually click rotate and just move your complex around. I always like to see the ligand and the metal. Once you're done with that, we can actually come over here to atom selector, and when you click on a specific atom, it will actually be highlighted in orange right here. Keep this in mind, and what I like to do is I like to open Notepad and start writing down which numbers are assigned to my ligand, because in cases where you have a ligand with a ton of different, let's say, carbons, you want to make sure that you keep those in track. The next step is to determine how many fragments you're interested in. In my case, I'm really lucky again, and I'm only interested in the relationship between the nickel and the nitrocyle for the XES spectra, so I'm only going to pick 2. I will input the fragment details. So for spot number 1, I'm going to put it as the nickel center, and then for spot 2, I'm going to just put in the nitrocyle. So if you remember, mine was 2, and then to designate that I want 2 and 3, I'm going to put a comma in between them and just put 2, 3, and that's all you have to do. There are some specifications you can make if you're interested in, let's say, different orbitals, for example. You can do this by first selecting, let's say I am interested in nickel, and you can actually click this drop-down bar and select which orbitals you're interested in. I'm going to keep them as S, P, and D, but again, if you are interested in simply D, you can just click D and it'll carry on through the tutorial. But again, I'm going to keep S, P, and D. The next section is file contents. MOAnalyzer is really nice because it will actually fill this out for you. However, I'm going to specify that I do not want to include XAS because it will just give us a flat line and kind of give us unneeded data points. So again, I'm just going to click that off. But if you are interested in an XAS tutorial, please leave a comment down below and I will make one. For table details, I'm going to keep everything the same, except I'm going to change carbon into my metal center, and I'm going to change the percentage to 20%. Again, if you're using a different complex with a different metal, remember to change this. Sometimes I forget, so it's always a helpful reminder. The next step is to create table. This section is all about viewing the orbitals of interest. I'm going to close this first window because, as you can see, the only thing here is unoccupied orbitals, and I'm not interested in that for XES spectra. However, when I come here, I can see that they are occupied. And the next step that I'm going to look for is really high D character. So as you can see for this spectra, the orbitals that are of interest are 110 beta, 119 beta, 120 beta, 121, 122, and 123. So go ahead and write down your orbitals, and then we shall view the alpha ones next. Again, we're still in beta, so I'm going to close this. More unoccupied orbitals, close that again, and here we are. In this case, for my alpha orbitals, as you can see, it ends at 124. That has pretty high D character. So in this case, I'm going to write again 110, 119, 120, 121, 122, and 123, but this time I'm gonna include 124. Once you have your orbitals of interest, we can now move into graphical analysis. My MOs alpha were 110, 119 through 124, so I'm gonna include that. But then for beta, it was the same, but just without 124. So there we go. For MOs AD, you want to click and enter 0. For energy skewing parameter, I keep mine at 5. And then for units, I'm going to keep mine at electron volts. For orbital range, I already changed mine from 100 to 150 based on the orbitals and the orca.out file. I also chose to remove projection because that would give us the entire XES plot. And I'm only interested in the nitrocele contribution. And then in order to check to make sure that everything went well, you're going to click Create MO Diagram. This is the sign of a successful tutorial. As you can see here, this is my nitrocele contribution. So now we can finally create ASCII. So click that button and then you can name this whatever you want. For simplicity, I'm going to name it TUT, tutorial. And then I'm going to save. I wanted to show you the ASCII file for my XES file. It should only be 2 columns because again, I'm only interested in the nitrocele ligand. So you can go ahead and select all and then copy this and let's move into Excel. Once you are in Excel, you're going to want to paste this. And usually what I like to do is I like to come down to this drop down here and use text import wizard. Sometimes it can get a little bit funky. I don't know what happens with like the copy and paste, but I'm going to select delimited, move into next, and then you can play around with this actually a little bit just to see. I'm going to keep it as tab because space would cut off the 0 as you can see. So I'm just going to keep it as tab. Next, make sure you keep this as general. If not, you're not going to be able to plot your data. Then press finish. So you're going to want to click insert and click this little graph down here. And you're going to want to choose scatter with straight lines. And as you can see, here is the graph. I'm going to delete chart title and then I'm going to start by deleting these little extra lines. But I am going to go into format plot area and I'm going to make a really nice border around this. Let's see. I really like my lines thick, so it's really distinguishable from the XES line. And then for these, I'm going to keep them the same. I sort of really like it like that. For some reason in Excel, it doesn't ever make it the color that I want. So you want to go ahead and change that, especially for these. You can do the same thing with this. Let's say you want a different color. For my posters, I usually like to match the XES Spectra's color to the figure. So for my outline, I usually leave it as blue, but for the sake of this tutorial, I'm going to change it. And I'm going to do that by using the drop down, clicking series 1, then clicking black. And as you can see, it's really, really nice. These you can change to, I really like using either Arial or Times, but I'm going to use Arial for this tutorial. I like to keep my font around 10. You can do that. This is really all to your customization, of course, really just whatever you want. I just really like to make sure that everything is super, super consistent and formal. And there is your graph. Firstly, I want to thank my lab mates Carlos and ZJ. I derived the complex I used in this video from a paper that they published. I want to thank Dr. Stieber for her amazing mentorship and intelligence and just support. And finally, I want to thank you for listening. If you have any questions, you can tweet me at inorganichole. You can leave comments in the comment section. Thank you, and I hope this video was helpful.